Hello friends, if we search Google or YouTube for paper plane test flights focused on comparing different airplane designs, most results show someone throwing their planes in a football field, backyard or park, or even in a street. In other cases, the guy is throwing his planes inside a big room, warehouse or gym. Regretfully, all these tests are biased because they ignore scientific and technical principles that allow us to achieve trustworthy evidence. All results are no more than a rough guess, something you can't count on. Why do I say these results are inaccurate or not trustworthy? Essentially, because there are several factors involved in the flight of a paper plane, and those people don't measure those factors, and that creates a bias in the results. I'll explain this now. Let's start with the following. We want to know which airplane design can fly farther. The flight distance of a paper plane depends on the following factors. 1. The design. We assume we're comparing planes built with the same materials, using the same size and weight of paper. 2. The thrust, the power with which we throw the plane. 3. The throwing angle, the starting lift for the plane. 4. Maximum attained height, the drag that depends on the thrust and the design. 5. Dropping angle, the glide ratio after attaining maximum height. 6. Flying in a straight line. This means precise construction and fine-tuning. 7. Environmental factors like winds and air currents. These can be mostly disregarded if the tests are carried out in a closed venue, like a gym or a warehouse. If we want to compare this design with this one, for example, which can fly farther, we must test them under the same conditions, or at least under measurable conditions. For example, if I want to know which plane is faster, I can drop them from here at the same time, and the first one in reaching the floor is faster, because that plane cuts the air resistance easier. We have to put both planes at the same starting point, at the same height from the floor, and we let them go. In this case, both planes are affected by the same gravity, the same Earth's rotation, both have the same starting point, and both go through the same air. As we control all factors, we know they're equal, except for the designs, which are different. We can assure they won't reach the floor at the same time, due to the air resistance. Between this plane and this plane, the only difference is the aerodynamics, and this one is faster. Now let's go back to which one flies farther. We have two designs we want to compare. That is the difference, the design. So, to see the difference between design 1 and design 2 in a scientific manner without any bias, all other factors must be the same. That is, we have to use the same thrust when throwing design 1 and when throwing design 2. And we must use the same throwing angle or the results will be biased. The maximum height, the dropping angle, and flying straight are consequences of the design and the thrust. So those values, although they affect the flight distance, they are part of the outcome, not the cause. When we throw a paper plane with our hand, the thrust and throwing angle will be different every time. The differences can be very small or very large. That very small difference, or what gets us near perfection, we will only achieve it after thousands or millions of attempts. Now, there's nothing wrong with doing it like that. It's entertaining. It's like going back to our childhood. It's our human imperfection. However, if we want to play with science, we might be able to save time on thousands of throws and its consequences. With a paper launcher, we can achieve constant throwing speeds and different throwing angles. In this way, we can measure the angles and speeds and control these factors. In engineering, this kind of device would be a precision instrument that can deliver different controlled throwing speeds and angles. Maybe we can't make a machine with such engineering precision, but we can make something similar. These launchers must be adapted so we can measure the angle. This other one allows changing and measuring the angles, but it's not powerful enough. This model is very powerful, and we can even get it to supply different speeds if we add a resistance or different voltages. But we still have to adapt a way to measure throwing angles. If we use a launcher, we will see that every airplane design works better, performs best, at a level of thrust and throwing angle that is particular to each design. We can call this the sweet spot of flight. For this reason, if we want to know which plane design is better, we should compare them at the particular level of thrust and throwing angle where each design performs best. Of course, those designs that are very similar will need very similar angles and thrusts. This is most evident when we compare very different designs, like a rocket design against a glider design. This one cuts the air very easily, so we can throw it with high power. Now, if we use the same power to throw this one, we will see that this surface bumps into the air, restraining its flight, and even can deform it, taking it out of course. Once we know which is the sweet spot of each design, we just need to try and imitate these values when we throw the plane with our hand. To measure the thrust of the launcher, we can use the method shown in that video, where we only need a compact camera and a free video editor. Using a camera and a video editor, we will also be able to see the plane's pathways in slow motion, where they reach their summit and which is their dropping slope. In a gym, warehouse, or hangar where competitions take place, there can be environmental conditions that might affect planes differently, depending on the season, hour of day, sunny or cold morning, if there is air conditioning and what type, people coming in and out, opening doors and windows, wind blowing outside. There are many different things that might affect participants differently. Nobody knows in which magnitude these factors can influence a winner or a loser. But remain assured, these factors play a part. And of course, you can improve the performance of your plane, fine-tuning the design by ensuring symmetry, perfect folding, lifting a wing, and so on. But that is another topic, and there are a lot of videos about that. I am convinced that if we want to take part in competitions, or we are focused on excellence, we must apply this scientific technical approach in a methodical and organized manner, so we have no doubt about the value of our results. Okay, friends, I hope this material is useful for you when you fly your planes, and I hope you liked this video. If you did, please give it a thumbs up, share, subscribe, and thanks for watching. Bye-bye.